In this tutorial, we're going to set up our character so that we can export it into our previous tutorial. And we're also going to make a different skin effect so we can use more bones, because this I think has around 120 bones, and for each compatibility I think it's only currently accepting 72. So we'll add that in, and it'll all still work with the regular model class, and we'll still be able to do individual effects on each texture and everything, despite the fact that it'll all be a solid mesh. This isn't going to limit your ability to do different effects on different parts of the materials. We could add in an extra transform, say, to the head to make the head kind of look a little bit more in the direction of an object that you might want, and kind of provides a bit of a hint to the player that maybe they should move in that direction. I was going to mention before, I think I might have mentioned it, that you can add a controller here and a controller here. What I would actually do is just add a bone that starts somewhere in the mouth and comes so that it's perpendicular to the edge of the mouth here, and a clone of it on the other side. Just use the opposite X value to get the nub to the other side, and paint in some weights. Use the blend painted weights to smoothen it all out, and then you can move the mouth around, make him smile, make him frown, all that sort of stuff. Combined with these two controllers, you can make a wide variety of expressions and make him talk and stuff, and you won't need the morph targeting. The morph targeting will be more for if you're doing cinematics. So the first thing we're going to need to do is consolidate our meshes. Let's go to geometry select and grab the body, and actually let's go into here, turn on geometry and turn off shape, so that we're only going to be grabbing geometry parts. So then let's select all these, click OK. Next step is we'll go to edit and click on clone, not instance. We'll want copy. Sure, it's copy, and we want that 001 on there. Just let it do a 001 on everything by default. Now go back up to select by name. We'll start with the top one, the 001, and click OK, and then go in here and go collapse all. Yes, and we can go over all the 001s. These capital ones might be 010, but all the duplicate ones, make sure not the originals, and just go right click collapse all. And what that's doing is it's just creating into a basic editable poly. Once you have everything collapsed as individual editable polys, go to select the body, and the first thing we'll do is we'll use attach list. Click on that and click all the ones with the 001 or 010, all the duplicate ones. So control click each one that you need. Oops, not that one. And hit attach. Match material IDs to material. Okay. Now, if you select from list, you'll see this body 001 here. Change the name of it to kid. The next thing we'll do is we'll add a skin wrap modifier. S, it's skin wrap, and we'll add, actually before adding, let's set up the parameters. So I'm going to use face deformation with a fall off of 10, threshold of 1. It works for the scale of my character fairly well. You might need to play with some of these, like you might want to try vertex deformation and use a high fall off value probably, maybe turn up the distance inflation a bit, and just experiment with these values until you get something that wraps really closely. But you'll probably want something that animates so you can see that the wrapping is working. So once you get those, make sure you click on add, and then you go select by name, and we can shift click and grab all of these and hit pick. That'll pick all the original body parts with skin mesh associated with them. So if we move this around, should work pretty good. We can click on convert to skin, and what I would do now is we'll go select by name, and everything that isn't the new mesh, the new consolidated mesh, control click on all that stuff, hit OK, and then right click and say hide selection. So now you should just have that kid mesh when you click. Alright, so the next thing I would do is click on auto key. So probably the only thing that's really going to get messed up here is the legs, probably in between the legs, because we didn't do a perfect job of that. I would go shapes, and since we do have a freeze transform for this, we can temporarily change the animation for this. So let's go up to say 30, and we'll bring this left leg up and see what kind of problems we encounter here, because we didn't actually make this perfect with the idle. I think we might have smoothened it out with the other animations. So what we can do here is turn off auto key, select geometry, grab the character, and click on skin, make sure edit envelopes is on, and select vertices is on, and go into here and probably click right thigh, our thigh, right here, so that we got a bone to start with. Well, we're trying to add some influence. So if I were to guess, there's probably no right influence on this whatsoever. We go into weight table, change it to selected vertices only, and use options, show affected bones only. We can see here only the root and the belly are being used on these, and we should have some thigh influence from both sides, kind of balanced out so that it stays smooth in between. So we'll need to add a little bit to both, even though it might not look like it. Let's just pull this one up a bit so that it appears in our table, and we'll want to do the same thing with the left thigh so that they both give it a little bit of influence. I'll just start by adding some right influence to each one of these. This part in between can be a little bit tricky for characters. This one already has a bit of right or left thigh. We'll just add a bit of right so we can balance it out when it goes the other way. Now, it looks like in here, got some runaway effect going on. We're going to smooth this out a bit. Some of this we might even be able to pull down a bit. Go to the back. Everything looks decent back here. We can probably balance this stuff out a bit, so it's not, we don't have this jagged effect. But I think for this simple example, for now, we'll just kind of leave it. We can come back and perfect it all later after we have everything working the way it should. These ones here, I'm going to add some right thigh influence, just a bit, and we'll let it sort out which ones really should affect it later when we set it to only allow 4 vertices, or 4 bones to affect each vertex. Let's go edit, select all, and maybe bring these down a bit. I'm just going to clean these up, and I'll be back in a second. Well, maybe for now, instead of being a perfectionist, we'll just go with, make sure we got edit envelopes turned on. Click on mirror mode, and we'll copy the green to blue. That's left to right. Okay, something went wrong there. Maybe first thing we'll do is we'll click on skin wrap, and we'll click on collapse 2. And that should collapse it down, so we just got the skin on top. Let's go again to frame 30. Let's reduce this. I'm going to use 0.01 centimeters. Okay, so I did a mirror. I'm not sure what that's going to do to the weights just yet. Let's go to shapes, grab this. Gotta get out skin first. And I put this extra one here. So I'll just take that out, and maybe we'll test out this side and see if it cooperates the way it should. So we'll go to 30. Lift it up. Yeah, these center ones are going to have to be balanced separately. Can't use mirror for that. Turn off auto key. Go all. Click on mirror. Go into the skin. Make sure auto key is turned off. And we'll just modify these. This one has to have left thigh applied to it. And we have to use the absolute effect here so that it gets added into the weight table. And that should kind of take care of that seam in the middle. So even after you do the mirror bones, you may have to edit the seam a bit so that it's balancing out both sides. You don't get anything too jagged. But I would say this is probably good enough for this for now. Again, smoothing everything out, perfect it later. Just to avoid any conflicts when we import other animations onto this, I'm just going to grab this and going to go into wire parameters and disconnect the wiring for this for now to these bones. And I'm just going to manually animate the chain. It's actually a little quicker to do that anyway. We'll refresh on this side. Okay, now I found the wiring association here. So I'll just go to each one of these and I'll just hit disconnect, disconnect, disconnect. Okay, and I think this might be wired to this, so I'll just disconnect this chain and we'll animate this manually. Okay, it looks like I got a Z times 0.6 for associating this thing with the second tailbone. So I'll just hit disconnect for each one of these. And I'll go third bone, refresh on this side, and do the same thing for this one. In theory, I should be able to take all these keyframes for the controller here and delete them. Transform to 0, and should still retain the keyframe animation for the tail motion, and we do. So that's good. Now all of these should be compatible. I believe the ears too have their own. Oh wait, can make sure we use this. There we go. Yeah, they got their own. So the ear bones and the tail bones are separate, and they have freeze transforms. I wouldn't use transform to 0 for the bones for anything else, just for the shapes. So now what I would suggest doing is saving it out as a new file, maybe call it idle template or something, and that way we know that that's one, or even have 2 copies of it, just in case we do something to one by accident. And then that way we know it's something that we can import other animations that we've done into this one, and it'll be exactly the same model, the exact same bones, same names and everything for each export that we do. And it's not going to mess up the hierarchy or anything like that. The only thing we're going to be doing is importing the animation from the other files and applying them to this one. So I'm going to hit F3 here, and we'll go to bone only and double click on the root bone. Must be the root bone. Another tip I should add is if you ever decide you want to make modifications to the root bone or add to the root bone, just keep in mind that when you make a character, make sure that where you put that root bone and the configuration of the root bone on the first few bones, make sure that that's the way you're going to keep it, because if you want to change the root bone or add to the root bone or anything like that, it can get really tricky and it can mess things up. Let's go to geometry and control click on this. So now we got only the bones and all of them, and we got only the geometry, which is all combined into a single mesh part. So now we can go export selected. I'm going to say kid idle FBX. I'm going to replace that one. And I'm just going to use these first two, animation, bake it. We're going to go with 199. We're going to have to remember to always use 199. Otherwise we may end up with an incompatibility problem. I don't think we need this resample all. I'm not sure what that even does. If you're not sure, maybe just check it. I'm going to use the FBX 2012 and click OK. Might get a turned edges warning, that's okay. Just make sure it didn't export any of these shapes or anything like that. So now we'll go to the export and we'll copy it into our content folder. You'll of course want to make sure you got your textures in there. Not sure if embedding is supported, but either way it's actually good to be able to swap out your textures anyway. So let's go in edit this with Notepad++. I'm going to go Control F, find PNG, and we want the relative paths. That's the ones with the dot dot in front. So we'll select that and hit Control H. We'll replace it with dot dot slash kid slash, because that's the content folder we're going to put it in. Replace all, and I got two source folders, so I got to look for the other one that says dot dot scenes and do the same thing. Next we want to find geometry, hit F3. Once we get to geometry and the kid model, if you look under it, there may be animation curve nodes, translation, rotation, and scaling. Let's get rid of those because that's going to mix it up, because it can't take those sorts of animations on the skeleton because those are actually applied to the mesh. We're going to hit save. And then we're going to go into our content folder, make sure those are all added in, and you can just right click and go rebuild for each individual one. Make sure you're using the skin mesh model processor. On the previous tutorial I showed how to set that up. You'll get skinned effect. If you make any changes to the skin mesh pipeline code, I would make sure to click on this, click OK to kind of refresh it, come back in here and just go rebuild. So we're going to make some changes to the previous tutorial. If you open up that previous tutorial and go into the source code, for now I would comment out the walk and run that we did, and we'll just make sure that we can get that kid idle working. So you will want the content root directory to be content/kid or whatever yours is named for your folder, and make sure that this name matches up. We'll comment out all the walk and run stuff for now, and what we're going to do is we're going to add a skin effect that works like the regular skin effect that comes with Monogame. It's essentially the same, but we're going to make a few adjustments to it to allow for 180 bones. Actually, I think before we do that, let's open up the project that creates the DLL for the pipeline. So this is actually two projects. If you look over here on the right, we got the skin mesh pipeline, which is going to create that DLL for that one, which is just this source code for its processor. And then we got the model, which is just an animation clip, the player, which is actually fairly simple. So you got your animation player, keyframes, and you got your skin data. But we're going to go into the Monogame skin mesh processor, and we need to make one change in here. Added this constant int 180, and that's going to allow us to write out up to 180 bones instead of the standard 72. So anywhere you see max bones, change it to this max bones that we made right here. So I did that here and I did that here. Then we got to make it so that our shader and our skin mesh CS, or whatever the file is called, is going to allow us to use that many bones also. So I think this line is essentially the only line you really need to change, and just add that in there so we can do that. And we can hit build, and it'll build both projects. And we can copy those new DLLs over to the skin mesh DLL folder that we have with our project. So we'll go into the skin mesh pipeline thing here, go into bin, and this is set for release, and we want these two new DLLs. We'll copy them, and we had this folder in here, so we'll just paste these in here. And make sure you're using these particular, oops, gotta make sure that we close this first. Cancel, close, try pasting again. So back in your game, make sure your references are actually using those specific DLLs. So this might actually be set to another DLL somewhere else or in a different folder. So you want to make sure it's actually that one and just browse to it and click on it. In content, we'll have to open that up again. You can't have that open when we're updating that DLL. And just click on content down here, click on it, and I think that'll refresh it. So now you can right click on this and rebuild using the new version. Make sure to save your project. At this point, we'll want to be in content again. We'll want to go file, or we'll want to go click on content, right click and click add, and we'll say new item. We'll create an effect. I already added it. I called it myskineffects.effects. So I'm just going to open it up and show you how that works. So at the top here we have the usual stuff where we're just making definitions based on whether this is an OpenGL cross-desktop platform version or if it's more of a Windows style version. And we set the max bones to 180. It's usually 72. This is just our texture. I'm using anisotropic because the characters are usually fairly close, so we want everything to look pretty good. We don't want any kind of jagged edges along the edges of the seams of the texturing. Here we have our usual vertex transformation stuff. Get it within camera view, camera position, which is used for lighting. Same with the weld inverse transpose, has to do with the normals. This is our material. If you increase the emissive color, you can actually make them look a little bit more anime. And here we got our specular color, specular power, which is kind of how small and sharp those reflections are on the character. If the specular power is, say, 4, it's actually going to be really spread out. If it's something like 512, then it'll be very narrow shine. So if you want it to look more metallic, you'd use a bigger value. If you want it to look less shiny, I would boost that value, but I would also decrease the value for specular color to say something like 0.1, 0.1, 0.1. Shine Amplify is one that I added so that I could boost the glossiness even more for effects with the eyes. So I got a separate effect in here for the eyes where it realizes that the alpha value is a certain amount, so it's probably the surface that goes over the eyes, and it's hard coded right now to automatically just assume that it must be the eyes, and it will make it more shiny. Here we got our 3 directional lights, which can have diffuse color, specular color. We'll probably use that yellowish green kind of color for the reflection, and that's because he's in a forest, so it kind of suits the environment. And this is our typical fog stuff. We might not even use that with the character, but we might use it with other characters that are off in the fog. But with the main character, we'd probably select a technique where it's turned off. So there's different techniques down here. And we got this define here, which just makes it a little simpler. It's the same thing as doing the usual technique thing, where we name a technique and then we can ask for a technique by using that name, and that technique will essentially be which vertex shader and which pixel shader we're going to use. So this is actually taking that OpenGL vertex shader model that we had up here, because we're using desktop, cross-desktop version, or at least I am. So this can take in a name for the vertex shader, a name for the pixel shader, and it just applies it here and here. So that's what this is, and then we can just use this and it'll substitute this stuff in place of that. So we're creating a new technique that we can call for in our CS code, and if we use this name in quotes, it'll use this vertex shader and this pixel shader, which are specialized. We'll have a vertex shader for lighting and fog with all 3 lights. We'll have a pixel shader. It's also vertex-based lighting, all lights with no fog. And this one's the same thing except for 1 light. And then down here, these all have fog. We don't have a no fog version right now. You could make one if you wanted. So we've got a per pixel lighting, skin, and fog. And that's for all 3 lights. This one's just for the 1 light. So we'll probably be mostly using this one. That's like the maxed out version. We'll take a look at how that code works. As usual, we got our structure for passing in the vertex input, which goes into the vertex shader, and it's going to be taking this from the vertex buffer, and these are the values in that vertex buffer. So for each vertex, there's going to be position, normal, texture coordinate, which is your UV coordinate. And then there'll be 4 indices pointing to bones, or telling it which bones to use, essentially. And these are the weight amounts. So what percentage each one of those bone matrix transforms is supposed to be applied to this vertex. And it's getting the bones themselves. It uses this index to look up into here. So we're going to pass in the bone transforms as a parameter in here, and that's what it's going to use to transform those vertices. These are for each type of pixel shader, so we pass these from the vertex shader out to the pixel shader. We'll probably be mostly using this one, which is per pixel lighting instead of vertex-based lighting. So this one's way shinier because at every pixel you're recalculating the angle between the light and the surface normal and getting the exact amount of lighting that there would be at that point. This one just does those calculations on each corner vertex and then just blends the resulting values in between. So it's not as smooth as this one is. And with this one, you can make really glossy effects. We'll take a look at the vertex shader we'll most likely use the most, and that'll probably be the vertex shader per pixel 3-light skin vertex shader. The way that's going to work is it's going to call this skin, and it's going to provide all the information that was input into the vertex shader in the first place. So this is basically just substituted. So it's up here, and we can use it in each of our shader functions, and we don't have to repeat the code each time. So we got a 4x3 matrix, which is going to hold 3 rows of our skinning information. So there's going to be 4 bone influences for each vertex. It looks up the influence index right here. Keep in mind too, if you only have like say 2 bones influencing a vertex or whatever, that's already going to be factored in, and those will just be empty. So they won't be contributing to this at all. They'll just be zeros. It's adding everything up so that it can create a percentage amount of influence. So if there was only 2, this would be like 50% maybe of one and 50% maybe of the other. But since there's usually going to be 4, it'll look up which index to use, or which bone to use, from the vertex, which contains an index to which bone to use, and it'll multiply that bone matrix transform by the percentage that it should influence it. So maybe the first one's 25%, maybe the second one's 30%, maybe the third one is 20%, but it'll all add up to 100%. Then it uses that final transformation combination to affect the position. So it transforms it to where it should be. And it uses the same tactic to also adjust the normal to where it should be. So now we can calculate the common vertex shader output per pixel lights information, passing in the position and the normal, and capturing it in one of these types of structures that we define up here for per pixel lighting. Position, the world space position, normal, world space, fog factor. So for per pixel lighting in the vertex shader, all it's going to need to do is transform the position and also capture the world space position by only using the world matrix applied to the position, because we don't need it projected to the screen coordinate for that one, but we will need that world space position and interpolate it in the pixel shader so that we can calculate every individual pixel lighting. So then we do the same for normal. We get the world space version of the normal. We use that world inverse transpose to calculate that normal, and we normalize it so it's just the direction, because we need the normalized directions to get an accurate dot product. And for fog factor, I'm not 100% sure how this works actually, but it looks like we're using a dot product, so it's like a percentage difference here, almost like an angle, and using saturate to kind of clamp it. Using position and the fog vector value specified, so that's like the start position and the end position, and dot product between the two to figure out the fog factor. Okay, so that's the sort of the fog scalar essentially. So let's go back into here, and this is defined up above, and all it's doing is it's copying those values into our outputs. So the normal world space, position world space, so that's all that is. It's just copying those values, which it captured here. For diffuse, we're going to be calculating diffuse instead of calculating it like we do inside the vertex shader. We're going to be calculating that on the pixel shader. So we're just sending the diffuse as 111, which is white essentially, and providing the alpha amount, providing the diffuse color alpha. We also pass on the texture coordinate, which we do the same for all of these. So going down to the pixel shader that we're going to use, first here, we sample off of the texture at the texture's UV coordinate, and that's what this does. And we multiply it by the diffuse value that we send in. So that's the material color. Using 111 means it's going to be 100% of each color channel, and we're also factoring in an alpha amount. We'll probably leave the alpha usually at 100%, so it'll probably be 1 also. So it'll probably just essentially be the original texture color that it gets here. Just depends on whether we've made a change to the alpha. So then we calculate the I vector, which is the vector that points from the pixel on the surface, which is this here, towards the camera position. So we create a vector by getting the difference between the camera and the current pixel position in world space, not on the screen. And then what we need to do with that vector, we normalize it so we just have the direction of that vector. And then we get the world space normal on this pixel on the surface. Make sure we just have the direction of it using the normalize. And what we do is we find the angle between the two. So we can use that to calculate the lightings. So we go to compute lights, passing those in, and saying that we're going to use all 3 lights in this case. And so in compute lights, taking those 2 directional vectors, what we do is for each light, looks like first of all, we're just storing the light information in these 3x3 here, which is what it's doing here. And also storing the half vector, which we use sort of like a cheat version of Phong shading. And we just get the direction of that. It's the difference between the light direction and the direction pointing toward the camera from the surface. So we store that half vector for this light. So down here, we've got a float 3, which is 3 floats essentially. And we're finding the dot product between each light and the world space normal at that position. So it's kind of like finding the angle between the two. We have to use the negative light direction. And then we get the dot H, which is for the half vectors and the world normal. And that's used in conjunction with the specular lighting. So that's that shiny spot that you see on the surface. And I believe this step float 000.L thing is just making it so that the lowest this lighting factor can be is going to be 0. So it's going to be between 0 and .L. So then we multiply that value that we got, this 0L here, by the .L to get the diffuse factor. What I notice here is you could end up with negative, this will always be positive. I'm not 100% sure on why this is the way it is, but I think I understand how it works. So we use the angle between, the half vector angle essentially, between that vector and the world normal, multiplied by that lighting intensity value essentially. And then we make it to a power of the specular power, and that gets our specular intensity value. So then we can calculate our diffuse lighting by multiplying the diffuse value that we got here with the light diffuse, which is the color of the light, and we take that result, multiply it by the diffuse color, that's the material color here, and adding in an emissive color. So we can boost or amplify the color, make it a little bit more cartoony. It doesn't actually light up the material. That requires a little bit different shader effect, but it does make the material look brighter. So then we calculate our specular value, again using the specular color multiplied by the specular intensity that we calculated here, and then multiplying that by our material specular color. So what do we do with this result that we get back? It's got that color pair, the diffuse light and specular light. We multiply that result by the texture color that we're sampling. So each color channel is going to be multiplied by some intensity of color that it expects for the diffuse light. I added this in to make the eyes look shinier. The alpha value is under 0.8, and there's a certain amount of specular color, and this is going to be pixel on the surface that we're going to want lit up. We're going to want it to really shine. If it actually has specular value, so this could be R, G, or B. This doesn't really matter. I just picked R. But if there's some specular lighting here and this is somewhat see-through, I'm going to assume it's the eyes or some kind of see-through material that might be really glossy. And I add in this light result specular. So I'm adding even more of the specular effect to the color, additive blending it in. And I change the alpha to 1. So that shine is going to be really solid. And I make an adjustment over here, so it kind of has a bit of a halo. So it's not normally like this. It's normally, there isn't a shine amplify even. It's just times color.A. So it'd be the color plus equals the specular amount for specular color intensity, and timesing that by color.alpha. So it gives a little bit of the see-through aspect of the material to the specular. However, what I'm doing is a little bit different here. I'm assuming that if ever there's a specular shine should show up regardless of whether the material's see-through or not. That's why I got this 1 minus color alpha times 100, boosting the shine amplify based on the distance between 1 and the color alpha. So this part's really hard to explain, so just assume that it works. And all this does is, you could even just use the shine amplify if you wanted, but this just adds this extra halo. All this does is boosts the specular amount even more. This is the original, by the way. And then what we do for the final color is we do a linear interpolation between our final color and some fog amount, which is determined by this fog factor that we calculated in our calculation up here, which is the dot product between the position on the surface and the fog vector to get how much fog effect there should be there. And so this is your amount factor. So it would be between 0 and 1. And we're interpolating between the original color that we wanted and the fog color with an alpha amount applied to it based on how see-through it should be. I'll just kind of lightly touch on what these other ones are and what they do. So this is the vertex shader for doing vertex shader based lights. This is the one for doing it with a single light. We'll be using the per pixel one. This is the pixel shader for vertex lit skin fog, so the vertex lit version. This is the vertex lit one that does not use fog. And this is where we can pick our techniques in our skineffect.cs based on what we're trying to do at the moment. I'll just briefly go over the code for my skineffect.cs. So right here I got this little mini class for the directional light. The direction of the light, the color, specular color, whether it's enabled or not. I don't even know if we really need that. I got a max bones of 180 instead of 72, allowing max weights per vertex to be 4. We could even potentially change this and change the shader to allow more vertex weights if we absolutely had to. 4 is pretty common and pretty optimal. So we've got a reference to our camera, we pass in. We got our effect that we're using for our skin, which can be changed if we need to. And we got our diffuse texture, default texture. The diffuse texture is updated during the draw. I'll show you that down below. Diffuse color, emissive color, specular color. This is all stuff that's kind of set early on. These are just some default values we're giving it. Ambient color, which is the lowest amount of light that would be visible. There's a prefer per pixel lighting. That'll be true by default. One light is false by default. We're using all 3. Fog enabled, false, but we could enable it for other characters. And this is just a list of our directional lights. We're going to be using all 3. The default alpha, fog start, fog end. Fog start and fog end will modify for sure if we're using fog. And we're keeping track of the world matrix as well as the world view matrix, which we'll see why. So in our constructor, we're going to need to be able to load stuff. We pass it in the content manager. We need to know about the up direction and where the camera is to create the eye vector for our lighting. So pass that in. We name the effects file that we're going to load, which will be that skin effects that we made. By default, we're enabling all lights, and fog, we have it turned off by default. So we're just initializing those 3 directional lights, doing the usual, just loading the effect, copying the camera reference over, loading the default texture, which probably a blank texture or checker pattern or something. Probably better to use a blank texture so you can just do material stuff with it, like material colors and such. Set some identity bones, leaving them as identity matrices, and then that way we can set the bone transforms initially to those identity bones. So that's just initializing values. And we're initializing some values on the card for those shader parameters. We'll toggle the default lighting by default. And if enable fog, then we toggle that. For our set bone transforms, we'll be using that when we're rendering the model. We'll call set bone transforms and pass in those bones right here, which are passed into this parameter here. And these just make sure that we didn't do anything silly. When we enable the default lighting, effectively what we're doing, we've got an up vector here, which we multiply here so that the light's going in the correct direction. We're just setting an initial direction for the main light that we'll use. And if we're using all the lights, which we probably will by default, then we'll add in these other 2 lights. which have a slightly different direction and some slightly different lighting information. These three here, actually I'm going to take these out of here and put them over here, because these three are going to need to be updated no matter what. And then 1 and 2, those are only if this is all lights on. Here you have the option of setting directional light. All you're doing is copying the information over, which you bring in here, and putting those on the card based on which light it is. This is for setting the start of the fog, the end of the fog. We did the same thing with the other skin effect, or no, we did that with the model class, I think. This turns the fog on or off. In the comment that they provided in the original, I just copied it over. We want to transform vertex positions into view space. Take the resulting depth value, Z value, then scale and offset according to the fog start and distances. Because we only care about the Z or depth component, the shader can do all this with a single dot product, using only the 0 of the world view matrix. We don't need the perspective projection, we just use the world view. So we calculate our multiplier here to get our percentage. So it's like the 1 divided by the fog start minus the fog end. Okay, and we're multiplying that by each one of these components of that row. Okay, and that gives us our fog vector from the world view. Makes sense, which we can pass in here. So during each frame, when we're drawing this mesh, we're going to want to call set draw params, and that'll give us the updated camera, because it's going to need to update it in the effect. So it'll give us the updated camera position, so that eye vector will be updated properly, as well as which texture it should be using as the diffuse texture source. And the texture doesn't have to be updated in here, that could be done separately, but this is just one way to do it. So the first thing we're doing is we're getting the world view by multiplying the world and the camera view matrix together, and that'll be used in here with the fog vector calculation. We also need to calculate the world inverse transpose, which we use the normal, and we get that from the world transpose first. So we calculate the world transpose, so we created an inverse first for the world matrix, and then did a transpose of it, that result in here, to get the world inverse transpose, which is what we need there. Okay, if it sounds like I'm a little bit confused about some of this code, that's because I'm not actually the one who originally made it. I just copied it in here, made a few modifications to kind of make it work the way I want it to. And here we factor in, pre-multiply the alpha values into each x, y, and z value of the diffuse color, I should say, and pass along that alpha value so we can use it in the shader. We do the same thing with the emissive, which is calculated from a multiplication of the ambient and the diffuse. So I guess we don't need to pass ambient onto the card because ambient's already factored in here. And so the emissive value kind of takes care of all that, brightens it up or darkens it or whatever, so mostly brightens it. Okay, so then we've got to pass in our world. We've got to pass in our world view projection so that we can get the screen coordinate. And we do that by multiplying world times the view projection that's already pre-calculated. And we've got to pass in our camera position so we can do the lighting calculations. If there is no texture, then we use the default texture, but if there is, then we pass in the diffuse texture to be used. We'll also need to pass in the world inverse transpose for those normals again. Diffuse and emissive colors will be updated. Yeah, and if this isn't done every frame, these might not need to be updated, but then there could be other things happening in between draws where these could get changed. So that's why these are being set every frame. So this is where we figure out which technique we should use. If, say, fog is enabled and prefer per pixel lighting is also enabled, then, and that's probably going to be the case for us. Actually, no, we probably won't be using fog enabled for the main character because they'll always be close to the camera. So it's probably going to use this one here and choose it. If we're using a single light, it'll probably choose this one. If it's with fog single light, it would choose this one. In the case that it's all lights, but it's not per pixel, then it'll use the vertex shader version. So that's how it's choosing those techniques. Then we apply the technique, and then it does the actual drawing. So this would be done right before we do our draw primitives. Here we have some other parameter setting methods that allow us to just directly change those parameters. Since these are actually set already every frame in set draw params, this just updates these values inside this module. In the case of specular color, we're going to change it right on the card, and same with the specular power. For shine amplify, I'm not keeping track of it in this CS, so it just changes that value directly here. So we'll go into game 1 and find out how we can use this with the model class. So in our game 1 class that we were working on before, I commented out these. I added these, but I haven't commented out for now because we're going to test that kid idle. And so I also commented out the walk and run stuff here, as well as here and here. We'll uncomment all this stuff later when we go to use it. I realized too that it might be possible for us to just export the bone animations for the walk and the run and not worry about the mesh, and then just apply the transforms to the character when it does animation blending. If we have unique versions of the character where the character changes shape or form, then obviously we'd want to keep the meshes with those ones. Okay, also here an update. I commented out this, and it doesn't matter whether we do the rotation or the scale first, but the translation does have to come last. So I times equal the matrix for the hero rotation by a scale, and I'm going to say it's going to be 40% because otherwise our character is a little bit too big for this scene. Might even want to go 30%. I'm going to try 40% first and see what happens. Going down into the draw method, this stuff is still the same as before. We had these disabled until we need them in our shader. So if we're going to do any point light stuff, this stuff might come in handy. If we're going to do any kind of shadow mapping, I guess you would call it, for like realistic shadow mapping, then we'd use this sort of stuff in there. So I commented out all this stuff and just temporarily set blend transforms to idle get skin transforms. So we'll have to remember to get rid of this line when we uncomment this stuff, otherwise it's not going to work right. Okay, so here I made quite a bit of changes to the render character here. This is just the shadow code and the code for drawing the eyes, which is a little bit different. I got it commented out for now. So for each model mesh in hero idle.meshes, so our base mesh is going to be idle. That's the one that's going to need to contain all our geometry for sure. And so everything's going to be based on that. And then for each model mesh part, so instead of going through the effects, we're going through the parts instead. For each model mesh part in mesh.mesh parts, we grab the effect that's associated with it, because that's going to hold the texture reference, so the texture that got loaded in automatically, and we just need to get a hold of it. So I'm saying old effect is equal to, and then we got to cast a skin effect because we have it as a skin effect in our processor, and I say part.effect, and we also get from it that old effect right here, old effect.alpha, and we can extract other things from that too if we wanted to, and we're applying that to the hero effects.alpha. So that's that skin effect that we made, which I declare up here, my skin effects hero effects. I don't know if I showed that before. We also have to load that in. Where did I load it in? I loaded it in up here. So we pass in and load content, camera, and we call it my skin effects or whatever you named it. Just make sure that this is all spelled right. So we got the transparency from it, so we can use that to determine whether or not it's the eye, and then we can use this shinier method down here. And that's why I have this line here. So if the alpha is less than 0.6, we know it's the eye. We're going to do it a little bit differently. So we'll skip over it in this one. It's sort of the opposite down here. If it's over 0.6, we assume it's already been rendered and we just skip it. So we make sure we got per pixel lighting turned on. We may have done a shadow down here where we have this turned off, so we might have to turn it back on. Set the diffuse color because we did shadows down here probably. We set it to black down here. Let's make sure we set it to white up here. Specular color and specular power we set, and 256 is pretty spread out, and I keep these values really low because for the character's main material we don't want a lot of specular. Oh yeah, you're probably wondering about the texture too. Part of the reason we got this is down here you'll see this set draw parameters, and we use that we extracted here to set this texture. So we can actually access which material it is and apply different shading techniques to each material individually, and even swap out materials if we want to have them wearing a different shirt, like something from Animal Crossing. We can do something like that. We got to make sure we pass in the blend transforms. Once we get all this working, we know everything's working good. We'll take this line out and we'll use the blend transforms for the animation interpolation here so that you can blend from idle to walk to run quite smoothly, or to whatever other animation like jumping or whatever. So before we used to have a line here that said, I think it was something like blend transforms, and it's something like mesh.parent bone, and then times all this stuff. We don't want to do that. Make sure you get rid of that and just change it to matrix hero rotate, or whatever. Maybe you have this as player matrix or something. You can even calculate this in the update and just pass it in as player matrix. But we've got the hero matrix, rotation matrix, which also has the scaling built into it, and we're multiplying by the translation matrix, so where in world space the hero is. And then we set our draw parameters. This is going to update everything, all our camera parameters, so it can do the right lighting, the texture parameter, as well as updating the diffuse color that we set up here. Then we set our vertex buffer. We set our index buffer just by saying it equals index buffer. This is different than saying mesh.draw or something like that. We want to do it like this so that we can set our texture here and just draw straight off of this. So we're drawing the primitive list, the triangles, at wherever the vertex offset is for this part, using the start index for the part, which is probably going to be 0, and then the part primitive count. There's going to be a different part for each texture here, something to keep in mind. So it's going to be changing the textures based on which part it is. So our consolidated mesh will be broken up based on textures. Okay, so everything else should be the same. Just build it, make sure it works. Okay, looks okay. He looks a little bit larger than I expected. We'll maybe bring down the size a bit. I'll try a scale of 26%, 0.26. That looks about right. Let's try turning on the shadows and the shine just to see if those are working. I just keep them turned off for testing purposes in case something gets messed up. So a little bit on the shine here. We set the shine amplify to 100, so that's going to really boost up that shine factor. And it's only going to be rendering each of the eyes here, the eye surfaces, because it skipped them here, and it's checking to see if the alpha is over a certain threshold here. So if it's under 0.6, it's just going to assume it's done already. It did it up here. And then when it finds the eyes, the two eyes, it's going to render them using a lower alpha value. It's sort of a bluish tint on the diffuse color, just to kind of give it that illusion of a sky reflection kind of going on. And we set our specular color to be extremely high, far higher than 1 for each channel, and set the specular power to 256. So it's a little bit spread out, but well, actually this one actually should be a lower value to spread it out more, and this is more of a sharper value at 256. But this doesn't really matter here because we got this turned way down for the specular color. I could turn it down even more to make sure that the body doesn't really shine at all. It's just kind of a clothy material anyway. Basically everything else here is the same, and we got to remember here to set hero effects alpha back to the original alpha amount before we exit this loop. This will probably just do a couple loops, do the eyes, and then we set the hero shine amplify back to 1 instead of 100. In the shadow, I make sure to set the per pixel lighting to false. Alpha is 0.9 as it was before. We're using diffuse black, times equaling the shadow transform, same as before. We set our draw parameters. I'm passing in null, so we can use the default texture or whatever, it doesn't matter. It's just going to make everything black anyway. And we do the same as before, and we just draw the primitives the same way. Well, since we know everything's working okay, we can go ahead and see if we can get those other animations applied to the character and do some blended animation. Let's go back into our 3D software. So for each of our animations, we'll make sure that we're using the 200 frames. So we'll export it as 199. Make sure we've got helpers open here too, so we can select anything that's animated. So we'll go to selection type all, grab everything, and say animation, save animation. We'll save it as a walk animation. And we'll do the same thing for the run. And I adjusted the animation for the run so that it's 200 frames and stretched everything out so the keyframes are matching up using that little tool on the bottom here. We'll check our layers again, make sure that we have the stuff we need visible, and grab everything, make sure there's nothing frozen in there, and go save animation again. We'll load up that idle template one that we made with the consolidated mesh again. In this file, we'll need to do the same thing, make sure everything is visible, grab everything, and this time we'll go load animation. Let's load the walk animation. Testing it out, it looks like the animations combined in an unexpected way. We may have to clear all the animations here before we do that, so let's just hit Ctrl Z a couple times. and we'll just grab all these keyframes and hit delete, and we'll load the animation again. So it looks like there's some initial transform offset that's different from that animation. So we'll bring this down. In fact, I'm going to go transform to 0. Bring this back a bit just because he's walking and he may be looking further out. And I'll bring it down a bit. And we'll test out the animation, make sure everything looks right, tail works the way it's supposed to. Looks good. Save this as a new file. And we'll go into Bone Select Only, double click on the root, go into Geometry Select Only, control click on the mesh, go into Export Selected, we'll export as a walk FBX, same options as before, make sure to bring it down to 199 frames, you need those to be exactly the same, and export. Let's open that original template again and apply the same procedure. Again, we'll want to make sure we select all, select everything, and drag select across the keys and delete those keys. Then we'll go into animation, load animation, click on the run kid animation and load it. Again, this one had a different default offset. You can click on it, alt right click and go transform to 0. It looks like it's still not quite right, so we'll transform this so it's ahead of the character. This actually, we can use this right here and just say 0 on the x-axis. As far as rotations go, we can set this one to 0 and this one to 0, even though it doesn't really matter much. And let's move this a little further out, because he's looking a little further ahead now. And we'll test out the animation. Looks like we have some unexpected turning that could be a leftover key that we didn't get rid of from the idle animation. Okay, so it was doing the same thing again for some reason. Just gonna modify those keyframes or get rid of them. If we go into the curve editor, we can see them here. Not too sure why that happened. Just gonna scale them into 0. So I just turned on auto key, and for a few of these frames I'm just going to manually plug these into where they should be. I might even add a little bit of variety, so he's kind of looking around a bit while he runs. Everything looks okay now, so I'm just going to grab onto that root bone with bone mode only, double click it, and grab geometry only, control click, and again export selected as run. Same options, make sure to go down to 199 frames and okay. And then I'm just going to double click on each one of these and do the usual modification. Find the PNG, get the relative paths, use Control H, place all, do the kid path. I got 2 types here to replace, so doing that for both types. I'm going to hit Control F for geometry. And got the geometry kid, get rid of these animation curve nodes for translation, rotation, and scaling on the geometry. We don't want that. And we'll do the same to the other file. Now, making sure we've added those two into the kid folder and make sure that each one of those has the skin mesh model applied to it. We can rebuild each of those. Back in our original code, you'll need to make sure you add these 2 lines here for the walk and the run. Make sure you got the walk and run here too. And we'll uncomment these skin data stuff, uncomment transforms, same here, and the starting of the clips, we'll uncomment that there and there. We'll go down to the update and make sure to uncomment the updates for those. Moving down into draw, we'll uncomment the animation blending stuff we made in the previous tutorial, and we could recomment, or we could comment this, or we could just delete this line. I'll just delete it because we were calculating our blend transforms here now. We're not just getting them from idle. Okay, let's see if that works. I might have to actually adjust the character speed because this was actually made for a different character before, so the animation and character speed might not match up the walking and running. Oh, let's see if this works. It does kind of work, except I'm noticing with the walk, and I think it's because of that imported animation, it doesn't like that. It's not capturing it the same way. So the eye is kind of coming part way out of the head. Alright, I think I know how to fix that though. Okay, let's see how this is gonna work. You'll notice I added a couple extra bones to the mouth so he can do more facial expressions without having to use morph targets. Still got to add that collision detection in there. Kind of seems strange being able to walk through the trees. For something like trees, I was thinking we just have a top view map, since it's kind of an RPG world. And oh, looks like we got a little bit of a problem with idle animation, where the eye kind of comes out the side of the head a bit, and the fingers are a little bit too long. So we'll have to fix that up. And I would say that is almost without a doubt a problem with the importer not combining some of the matrices. So we might have to work out a way to make sure that the exported data has all the matrices combined already. Or modify the importer so that it makes sure that everything's combined correctly. So what I was saying is we could have top view version of the map and add circles in. What I would actually do is I would just take an image of the top view of the render, or better yet, what you could do is just kind of use that map as a basis and then create an editor where you can plop down circles with a radius and just kind of match it up to where the trees are on that image map. And if you got houses, you could put squares where the houses are. If you got characters, same thing, just little circles that you slide around the character that's standing there. Maybe benches, you could make it so you could sit on them. Just give them a different signature so that the map knows that it's something you can sit on from a certain angle. And if I wanted to make it into sort of a platformer and add jumping and things you can jump on top of and stuff like that. If it's something simple like box shapes, it's just a matter of doing a circle radius or a sphere radius for the character, or ellipsoid if you use two radiuses. So one for the up-down radius and one for the horizontal radius. And just do a typical radius versus plane type collision detection and make it slide. You got to do the corners and edges a little bit differently depending on the velocity of the character, but that would get into a whole different tutorial series and a lot of complicated math, which I don't really have time to do right now. So I have my own project I'm trying to work on right now. But I'd probably just start simple with the circle on circle stuff and the circle on square stuff. And to get into platforms and stuff like that, it's just a matter of adding slightly more complicated primitive testing, where you're doing a sphere, which is the same sort of concept. You're doing a radius test against surfaces, but instead of just a line, you're doing it against planes instead. Polygons and planes and such. And you can walk on top of them, jump off of them and stuff like that.
I like that.
For really complex collision detection, you have to do like a broad phase and narrow phase sweeping tests, and some of that stuff can get pretty complicated. You got to break down your geometry into, in this case you wouldn't use octrees, probably just quad trees, but break it down so that you're only testing against stuff that's close to your character. And that's where the quad tree comes in handy. So it's working out what is closest to your character and what it should do collision detections with first. And you go with the shortest distance, and that's the shortest distance of a collision is, and you kind of have to do it recursively. The shortest distance is the one that you want to push the character back out to. The character actually isn't into the object or hasn't actually moved into that position yet, so you're not actually pushing them out. You're predicting where they're going to go, which is sort of the same thing with 2D collision detection. You kind of want to predict where the character is going to go and make some sort of compensations to the vectors, the motion vectors or the velocity vectors, based on where they can and can't go, and shorten the vector to something reasonable. Just gotta adjust the walking speed so that it kind of matches up with the animation a bit better. There's a lot of freedom with this camera. I kind of like it. We technically could make it so that when you push a new direction, the character doesn't suddenly face that direction. But I find though, even though that looks better, it's going to frustrate players a little bit because the gameplay is not as responsive, and if they need to react to something quickly, sort of instantaneous motion will make them a little bit happier. So far, the only thing that I can tell that's going wrong is the idle animation. Same sort of thing seems to be happening on both sides of the head. I know though, if I load this animation, any of these animations, into another FBX viewer, it seems to work okay. So I would say it's a problem with the importer not combining some of the matrices quite right. It could even be something simple like there's an extra scaling matrix, which actually might be that one that we took out that's built into the mesh, that is supposed to widen the head a little bit, and it's not doing it. So we got parts of the eyes coming out of the sides of the head during the animation a little bit. We can brute force fix it up, I guess, but be preferable to get it working the way it should. I'm working on another FBX importer, which will allow people to modify the FBXs as they please and bring in new ones. So you could mod the game a little bit more easily. And it's based off of Will Motil's. Pretty much he's the one who did all the work for that. And so I'm hoping to make something like that and use that in my own game. But right now I'm working on another project, so I gotta finish that first before I come back to this one. But I wanted to get part of this out of the way just so that I could show people how to do some of this stuff.